Hey viewers, you're watching The Savera and I'm Vidhi Joshi. It's been 41 years since Rakesh Sharma looked down from space and said, Sare jahan se acha. Now, another Indian Air Force pilot, Group Captain Shubhanshu Shukla, is writing the next chapter. On June 26, 2025, he became India's first astronaut to board the International Space Station as part of the Axiom 4 mission, a historic private-public collaboration between Axiom Space, NASA and SpaceX. And this isn't just a symbolic movement. Shubhanshu isn't just traveling, he's conducting groundbreaking experiments that will shape India's Gaganyaan mission and influence the future of human survival in space. Why did India invest 548 crores? India paid Rs 548 crore for this single seat on Axiom 4. That amount covers astronaut seat booking, rigorous training, payload and research logistics. Why? Because simulators can only teach so much, but spaceflight gives real experience. This is a strategic investment in making India space ready, not just for Gaganyaan, but for future missions to the moon, Mars and beyond. What is the core mission? What are the 7 scientific experiments in space to be conducted by Shubhanshu Shukla? During his 14 days aboard the ISS, Shubhanshu will carry out 7 critical Indian experiments designed by ISRO and leading Indian institutions. These are India's first ever live experiments aboard the ISS. Let's break down each one. Experiment number 1, studying muscle loss in microgravity. Conducted by Institute for Stem Cell Science and Regenerative Medicine in STEM, Bengaluru. In space, gravity doesn't pull on your body the way it does on Earth. As a result, muscle tissues weaken and shrink from disuse, even if astronauts exercise daily. This experiment analyzes cellular changes in muscle fibers in microgravity, the role of myogenic stem cells which form muscle, potential treatments for muscle degeneration using bioactive compounds. The main impact of this experiment will be to help prepare long-duration astronauts and supports research for muscular dystrophy on Earth. Experiment number 2, crop growth in microgravity. Conducted by Kerala Agricultural University. To live on Mars or Moon, we must grow food in space. Shubhanshu is testing 6 different seed types including vegetables and cereals for genetic changes due to space radiation, cellular growth, patterns in zero gravity, chlorophyll and nutrient production under artificial light. Seeds will return to Earth for lab analysis to see if they grow better, worse or mutate beneficially. This is India's first step toward bioregenerative life support system where food, oxygen and waste are managed sustainably in closed environments. Experiment number 3, seed germination and root behavior in space. Conducted by University of Agricultural Science and IIT, Dharwad. We know seeds can germinate in microgravity, but how do roots know which way to grow without gravity pulling them down? This experiment will explore direction of root growth in absence of gravity, moisture absorption and nutrient uptake, whether gravity affects gene expression during germination. This data helps design future hydroponic systems in orbit. Experiment number 4, tardigrade, water bear survival in space. Conducted by Indian Institute of Science, Bengaluru. Tardigrades, microscopic creatures, are known for surviving extreme conditions, from freezing cold to space radiation. In this experiment, Shubhanshu observes how tardigrades respond to cosmic radiation and vacuum, changes in DNA repair mechanisms, their ability to reproduce in microgravity. The main goal of this experiment is to understand how life can be preserved in deep space and apply findings to human cell protection during long-term missions. Experiment number 5, effect of screen time on eyes and mental health in space. Conducted by ISRO's Human Space Flight Center. Astronauts use digital screens 12 to 16 hours a day for communication, system control and research. But in space, eye muscles weaken due to no gravity. Constant light or dark cycles affect focus. Mental fatigue can rise from prolonged screen exposure. This experiment will monitor eye movement patterns, use sensors to track pupil dilation and cognitive reaction time, study changes in mental clarity, stress and decision making. The benefit of this experiment is to improve training for astronauts and screen ergonomics for extended missions. Experiment number 6, cognitive load and stress in microgravity. The ISS is cramped, noisy, and operates on tight schedules, and weightlessness and even routine tasks become challenging. This experiment tests astronaut concentration levels under stress. Memory recall speed, effects of microgravity on brainwave patterns. Instruments used in the experiment will include EEG headbands, biometric stress makers, and reaction-based software. This experiment will help design mental health protocols or deep space travel. Experiment number 7. Cyanobacteria and biological farming in orbit, conducted by ISRO and supporting research centers. Cyanobacteria are tiny organisms that perform photosynthesis like plants. Shubhanshu carries special bioreactors to test whether cyanobacteria can convert carbon dioxide to oxygen in space. Their ability to purify water, if they can survive radiation and low gravity. The main goal of this experiment is to lay the foundation for closed-loop farming systems on future space habitats. NASA and ISRO collaborative experiments. In addition to Indian studies, Shubhanshu is collaborating with NASA on nutrient absorption tracking in astronauts, radiation shielding performance testing, hardware durability studies in microgravity, microbiome changes in the human body, suit material performance under extended wear. Why this experiment matters for Gaganyaan? Shubhanshu's experience is training by doing something no simulator can replicate. He is helping ISRO to test crew behavior and communication under real space conditions, refine safety protocols for emergencies, validate scientific instruments and suit systems, understand microgravity effects on Indian physiology and materials. This cuts down cost and risk for the first crewed Gaganyaan flight. With this experiment, ISRO aims to build India's first space station by 2035. Shubhanshu's mission isn't just for Gaganyaan. It's a helping test bioscience, microgravity farming and crew behavior, all critical for long-term life in space. Rupees 548 crore isn't just a seat to space. It's a ticket for the future. From muscle loss to space crops, from tardigrades to mental health, India is collecting insights that will power future astronauts, space farmers and space doctors. Shubhanshu's 14 days are a bridge from Rakesh Sharma's dream to India's interplanetary ambition. That's all for now. Stay tuned to the Savera for more updates. Do like, comment and subscribe to the channel.